function, and we wrote it out like this, where you had your 3 points with zeros. We've done it that way. We did a very, very small amount of this when we would write equations when we were in the polynomial stuff. I think we only did like 3 or 4 examples of this back in October. That was October. But what happens here is one of the things that we can do if we have the 3 zeros of a cubic function. If I get this to work correctly. This is for when you have the case of a cubic function. What does a cubic function look like when you graph it? Yeah, how many changes of direction does it have? 2. So basically you're looking at it goes up, down, and up.
Oh, no, I remember.
So in a cubic function is cubed because it can have up to how many possible zeros? 3 of them. So this is one way to write out the equation if you're given 3 ordered pairs, or 3 zeros if you will, because then you can get the 3 terms, and then you can solve by using one of them to get the value of A to tell different parts. Now remember, not all cubic functions have zeros. Some of them have 1 0, some of them have 2, some of them only have 3. It depends on the function itself. But this is for if you have all 3 zeros. And when we did this, get the example here. We did it where we had I will show you the next example. We had something like this. You had 3 ordered pairs, but a secondary point. And the reason why we had to have that 4th point was so that way we had some value to substitute in for x and y. And that way we solve for a. So this works out being kind of the exact same thing you guys did yesterday with quadratic, but you have 1 more term. That's about it, if you're doing this. So here you have 3 zeros. If we want to write the equation out, it's going to be y equals a, x minus p, x minus q. I think they wrote x minus r for the 3rd value. Well, I have a 0 at -1, -3. So those terms would be x plus 1, x plus 3. And what's that last term on the other side? So what's the term? The 0 is 3. What's the term? X minus 3. Good. And now we have this lowly little ordered pair here. That ordered pair is at what? -2 and 1? Which tells me what's your x value and your y value. Solve for a. 1 equals -2 plus 1, -2 plus 3, -2 minus 3. Yeah. Yes, sir.
So the P, Q's, and R's are all your zeros?
Yes, sir. Bless you. Bless you. Did you get 1/5?
Yeah.
Okay. So if that's your 0, then you can go ahead and write it out in terms of the equation then. So it'd be y equals 1/5 times the quantity x plus 1, excuse me, x plus 3, x minus 3. And these are the problems that we did back in October. Yes, ma'am.
How come we didn't just do this all?
I don't know, because we've rewritten Algebra 2 curriculum 3 times in the past 4 times in the past 4 years, and the way that some of the units have been set up is that this whole modeling thing is supposed to be its own standalone unit, but now that we see that the PARC test comes up sooner before we get to the actual modeling unit, which is all over the PARC test, we need to incorporate it throughout the school year. So next year, we'll be doing this throughout the school year. So using the calculator for the regression, using this a little bit, so it works out. Just hindsight. The other new part here is to decipher what we call finite differences. This is the new stuff. This is the stuff we did not talk about. This is how we're able to tell what type of polynomial we have by looking at what's called a finite difference. This helps us tell the degree of a function by doing math. Or better yet, subtraction. It's actually really cool. This is how we're going to be able to tell what kind of a function you have, what the degree power is. So what you wind up with something like this is you have some value of x, and then this becomes your f of x. Yes, sir?
When you're talking about degree power, you might go to quadratic, cubic.
Yes, sir. Yeah. Because the number of times we do this next step tells you the degree of the polynomial. So think of it this way. This is f of 1, f of 2, f of 3, f of 4, f of 5, f of 6. Because you're letting x equal 1, 2, 3, 4, 5, and 6. Okay. So if I look at this chart, what I can do is the following. I know that f of 1 is negative 1. F of 2 is 3. F of 3 is 3. F of 4 is 5. F of 5 is 15. 6 is 32. That's what that means by taking f of 1 and substituting it. We don't know what the function is, but I do know if I substitute in 1, I'm going to get negative 1. If I substitute in 2, I get 3, and so on. Excuse me. So here's what we do. We do what's called finding the finite differences. And all you do is the following. We're going to make this little chart. What's 3 minus 1? No, excuse me, 3 minus negative 1. Negative. What's 3 minus 3? 5 minus 3. 15 minus 5. 39 minus 15. 24.
Is it really?
Oh. Taking each consecutive subtraction. You're finding the differences between the values. Okay? We do it again.
All the way to
No.
oh.
What's 0 minus negative 4? Huh? 4. I thought you said negative 4. Huh? 2 minus 0.
I wrote negative 4.
10 minus 2. 24 minus 10. Thanks, Melms. We don't. I'm doing 0 minus negative 4, 2 minus 0, 10 minus 2. I'm going.
Yeah. 1 minus 3.
I did 3 minus. Oh, did I do that back? I'm sorry. I'm sorry. It was what? Did I say?
Yeah.
But I did. It was.
said 4 and you said negative.
Oh,
I wasn't right.
Okay.
Ha!
I'm sorry.
I was right.
There. Is that better?
I was right. both
I'm
times.
sorry. Am I allowed to make one mistake?
No.
That was 2 technically.
I'll do it.
Good.
I'll try.
You can't hear us.
What?
You can't hear us.
What? Thank you. So, is my subtraction okay so far?
Yeah, that's good.
All right. 2
Is it actually
minus negative 4.
Positives.
Positive 6. 8 minus 2. 14 minus 8.
Nope. I'm done.
So, are all 3 of those numbers the same?
Yes.
Okay. How many times do we have to subtract?
2.
So that just means that since you subtract it out twice, that tells you you're going to have what kind of a function. Is it going to be squared, cubed, linear?
Square.
Squared. That's what it means. Okay.
Wait, how do you know?
Actually, we did it once. Actually, I'm sorry. We did it 3 times, but the 3rd time it was that, so it's a 3rd degree. So we subtract first time, 2nd time, 3rd time. 3rd time's a charm, and we got 666. That means it's a 3rd degree polynomial. If we subtract the differences right the first time, it's all the same. So if I did right off the bat and I got 4, 4, 4, 4, 4, that meant there was a common difference between all of them, and it was linear. Okay. And we want to be an arithmetic sequence.
No.
It's crazy how these things come back around. Okay.
Starting from the right down to the left.
Let's try another one. That.
Just math is too much. Hey, I think something like that.
So we're going to look at this here. We have f of 1 is 1, f of 2 is 4, f of 3 is 10, and then it goes 20, 35, 56, 84. We're going to try to figure out what would the degree of the function that's creating this be. So our list is 1, 4, 10, 20, 35, 56, 84. So we'd go through the differences. And 21. Right? I'd do it again. Well, that's just creepy.
Yeah.
Then why do you have the next one?
Yeah, this classroom.
So here's our first, here's our second. So what's the degree of this one? 3. I had to do it 3 times to get them all to be the same. So this is a 3rd degree polynomial.
What if they don't all go the same?
If they don't all go to the same, go back and check, make sure you didn't accidentally do -1 minus 3 instead of 3 minus -1. But it is possible you
Don't
could have
do it.
non-polynomial stuff. Okay. But I'm pretty sure everything we're doing today is going to all have a solution.
Well, no, right.
You're still going to get 28 minus 21. I mean,
Yeah,
still,
it's gonna
it's
be
the same thing, yeah.
It's just gonna get easier.
No, I got you. That's fine. So what you have there is that you know that it's got to be a 3rd degree polynomial. Okay. So let's see if we can figure out how to write the equation. We know it's a 3rd degree polynomial, so that means it's got to fit in the pattern of ax cubed plus bx squared plus cx plus d equals y. Are we okay with that? All I'm doing is writing some sort of a standard form for this. So, back at the original problem, we had these points. We had f of 1, 1, right? F of 2 was something, f of 3 was, and then 4 was 20, correct? So you had those first 4 points, didn't you? Which means, remember when you did f of x? This is your x value, this is your y value. Can't I do that with all of this and do a system of equations as a 4x4 matrix?
Sure, that's what you got.
Yeah,
But that's just.
that's what we do. We do 1 cubed times a plus 1 squared times b plus 1 times x plus 1d equals 1. 2 cubed a plus 2 squared b plus 2x plus 1d is 4. 3 cubed a plus 3 squared b plus 3x. Sorry, this should have been c here. Excuse me. Those should have been c's. 1c. 1. This was a 2c. This was a 3c. Here we can create a 4x4 matrix by doing our alpha, is it alpha zoom?
Yeah.
By doing your alpha zoom and creating 4x4 and putting in your coefficients, just like you did with quadratic. So let's see, 1 cubed is 1. Eight, 4, 2, 1. 27, 9, 3, 1. 4 cubed is 64, correct? It is now. Yes, sir.
How do you know how many of the you said? Why are we using 4?
We're using 4 because we knew that it took us 3. So when you write out a third degree polynomial goes, you want to start at the highest degree and work your way down to nothing. So that means the third degree polynomial always had n plus 1 terms. That's why. And then I do the inverse of that to a alpha window.
Which one do you put to the one row or column?
It's 4x1 column. And plus, if you screw up, you can always go back and re-edit it. And then my answer column will be a 1, 4, 10, 20. And I'm getting fractions and then but I'm not getting an error. I'm getting, for my answers here, when I do this, I'm getting 1/6, 1/2, 1/3, and then negative 1.8 e to the negative 12. This means this is approximately 0. Yes, ma'am.
Hey, yesterday too.
Wait, what numbers do you put in cycle? Do you put the answers in? Do you put the...
What?
Is that what you're supposed to do? Put the 1, 2, 10, 20.
Yeah. 1, 4, 2,
4.
Yeah, 52 is 4.
Oh, was it this?
Yeah, I'm pretty sure 52 is 4. No, it's 4. I forgot to. Did you get that?
The only one you should have known is 1 sentence.
I don't think your exponent was raised all the way up. I just got -1. I don't know why I did that. I don't know why I raised that. If you hit the caret button, you hit the negative. Hit the x and negative 1. The x and negative 1. Did you guys all get that?
Yeah.
That just means your function looks like this.
So
1/6 x cubed plus 1/2 x squared plus 1/3 x is y. That's all it means. It just, in this case, it means there is no constant value. There is no, what do we call it? Thing.
Real number.
Yes. I was thinking about it. I imagine.
I definitely guess.
Yes, ma'am.
Wait, what do you do after all of, like, the numbers into the matrix?
What we're doing here in the matrix, once you get the 4x4 matrix, you do the to the -1 power times the column matrix, and then you're going to get this as your answer.
And in like the second one,
That's all.
just do the answers.
Yeah.
Like,
Yep. It's the exact same thing as that 3x3 we did yesterday, except it's a 4x4.
okay.
That's all it is. Okay.
What is the negative?
That's an approximate of 0. That's all it is. When you see something like that, -1.8, anytime you have an e to a -12, -14, 16, something along those lines, it means it's 0.
Do we all get sunglasses?
What's that?
We're working in the Matrix. Do we all get sunglasses? That was fun.
We watched some movie that we're doing.
Yes. Let's try it on.
Dodging bullets is pretty cool.
Let's try this one and see if we can figure out the finite difference and see if we can do the equation again.
Alright, let me write this down.
So let's see, we have 6, 15, 22, 21, 6, and -29. Not necessarily. I think that in order for finite differences, I think for finite differences to work, it does. Yeah, if you're using finite differences, it does. Otherwise, when we get to the graphing calculator stuff, you can still do it, but with different change of scales. So we do this. Is that right? I think that's right. Alright. So here's our first time. It's 20, excuse me. 35 minus has to be -20. -8 minus -2, -6.
It's close to curse.
-14 minus -8 is -6. And it's -6.
We have to get out of here.
It's actually leaving.
See ya.
Oh, wow.
Good luck. You can do a lap if you want.
It's actually leaving.
So how many tries did it get us to get to the devil? Wasn't it the negative devil?
Yeah.
So,
The
negative
anti-
double.
double.
That's
The anti-devil, yes. It's the devil's advocate.
Wow.
Is that what you just said?
No.
Oh, I
Wait, wouldn't
I
it,
said it's double
but
negative.
devil's negative. That's negative, so wouldn't it be positive?
yes. When life gives you lemons, you make lemonade.
Who gave you the lemon?
But you don't need, you need sugar for a good life.
What?
You need sugar for a good life.
I'm too sweet for sugar.
Wow.
In this class grade. Bad jokes all day long. So again, you can do the same setup and write the equation, but for right now, we'll just say it's a third. It will wind up being a third-degree polynomial. Third-degree polynomial means you're gonna have to use the first 4 terms in a matrix to set it up.
Yeah.
It's funny.
Wait, what if it's like, if it's a 4th degree, then it would be 5?
Correct. Because remember, if you have a 4th-degree polynomial, you always have n plus 1 terms, whatever your degree was. You feel better? Cool. Anybody else want to take a walk?
Yeah?
Go ahead.
That was
All right, let's go through the whole app. Get the double.
All right, dude.
My knee hurts now.
Feel better, Rod?
Feel better than water, wash the devil out of my mouth.
Yeah. Really good. Feel better after skipping?
I bet there's gonna be another problem like that. Just calm it down. She does not like it.
I told you. I said that. I said I had it.
I thought it was hard.
No, so many people are just waiting for some dumb page now.
Watch my new TV show.
Go ahead. Sure, we'll just put it.
Try those out. 47 and 48, you'll wind up using the regression on your calculator. So you'll have to play with the window. One of the things that you'll take a look at when you're looking at graphs is that some of the data sets you get, you can still do finite differences with them, but a lot of the data stuff, the numbers get a little bit larger. But remember, in a cubic model, how many changes of direction can you have? 2. You have n minus 2 changes of direction, n plus 1 terms. All right, for your degree. Degree minus 1 change direction, degree plus 1 terms. Does that make sense? Give those a shot. 32 from 40, those are the even ones. And you'll find the finite difference, and then you'll use a matrix to write the equation. Okay?
You're agnostic, so you